In this lecture of the signals and systems, we will see that what is a system and the different characteristics of a system. A system is defined as a set of device or functional blocks that are connected together in order to produce an output in response to an input signal. Let me repeat this again. A system is defined as a set of devices or functional blocks which are connected together so that they can produce an output when an input signal is applied to the system. System alone cannot produce the output. A signal must be given as an input to the system. After receiving an input signal, the system will process this input signal, and after processing this input signal, the system will produce a desirable output signal. So the block diagram of the system can be represented by, here an input signal is given to the system in order to produce a desirable output signal. Now think about the light bulb in your house. When the switch is turned off or no signal is given as the input to the light bulb, it does not produce any output signal. Whenever an electrical signal is given as the input, light bulb will process this electrical signal and generates a more desirable output signal in the form of light and heat. Here, as you can understand, the electrical signal which is given as the input signal is less desirable, and the generation of light and heat as in the form of output is more desirable. A system can have multiple inputs and multiple outputs depending on the type of the operation to be performed on the inputs. The inputs to a system is also known as excitations. Outputs corresponding to those inputs are known as response. The excitation of a system means that signals are given as an input to the system, and the response of the system means that the output generated by the system. Example of the system is a RC network. Here, the input signal is the source voltage. The output signal can be taken across the resistor or the capacitor. Both the input and the output signal depends on the same variable. If the input signal is a function of f, which depends on three variables such as f, t1, t2, t3, then the output signal, which is a function of p, will also depend on the same variables, or it can be represented as p, t1, t2 and t3. Another example of the system is the communication system. A message signal generated at the sender's end is given as the input to the transmitter. This transmitted signal from the transmitter is transmitted from the transmitter to receiver through a channel. Same or slightly distorted message signal is received at the receiver's end. The process of sending a message signal from sender to receiver requires a lot of devices to be connected in between sender and receiver. The proper combination of this device is known as communication system. Now, response of the system. Response of the system depends on the transfer function of the system. The transfer function of the system represents the relationship between the output signal of a system and the input signal for all the possible input values. Mathematically, the transfer function of a system is defined as the ratio of the Laplace transform of the output to the Laplace transform of the input, where all the initial conditions are 0. If the input signal to a system is xt and the Laplace transform of this input signal is xs, then in response to this input signal, output signal can be given by yt and the Laplace transform of this output signal is ys. The transfer function of the system can be represented by Hs is equal to Ys by Xs, having 0 initial conditions. We will know this transfer function in more details in the incoming lectures. Based on the number of inputs and outputs, the system can be classified as single input, single output system or SISO system. This is the block diagram of SISO system of communication. In SISO type of antenna system, there is only one transmitting antenna at the transmitter and one receiving antenna at the receiver end. This makes the SISO the simplest to implement and the easiest to design amongst all the four types of systems available. Here, the transmitting antenna is xt, the receiving antenna is yr, and the input signal is s. Output from the receiving antenna is y. Single input multiple output system or SIMO system. Following is the block diagram of the SIMO system. In the SIMO system, there is only one transmitting antenna and there can be multiple receiving antenna at the receiver end. This helps to increase the receiving diversity at the receiver end compared to the SISO system. Here, transmitting antenna is xt and there are two receiving antennas are yr1 and yr2. Here the input signal is S and the two output signals from the receiving antennas are Y1 and Y2. multiple input single output system or meso system. This is the block diagram of the meso system. In the meso system, there can be multiple transmitting antennas from which signal can be sent, and there is only one receiving antenna to receive the signals incoming from the multiple transmitting antenna, which means that there are different sources available, but there is only one destination available. Here, transmitting antennas are XT1 and XT2, receiving antenna is YR, and the input signal are S1 and S2. Output from the receiving antenna is Y. Multiple input, multiple output system or MIMO system. In the MIMO system, there can be multiple transmitting antenna from which signal can be sent, and there are also multiple receiving antenna through which signal can be received. In the MIMO, since there are multiple transmitting antennas, the signal can be transmitted by any antenna, and therefore the signal can follow any path to reach the receiving end. Based on the type of the signal given as an input to the system can be classified as one-dimensional system and multidimensional system. The system which works with one-dimensional signals like speech signal, heart rate, which depends on a single variable, is known as one-dimensional system. And the system which works with multidimensional signals like image signal or voice signal, which depends on more than one variable, is known as multidimensional system. Now, in this signals and system course, there are basically two types of problem related to the system: analysis type problem and synthesis type problem. In the analysis type problem, we have an input signal given to the system. We also have the working system, and depending on this input signal and working system, we have to determine the output signal. Solution for this type of problem can be found, and they are actually the general solution, and they are also known as the general problem based on the system. In the synthesis type problem, we have an input signal, we have our desired output signal, but depending on this input signal and the desired output signal, we have to determine the system. These type of problems are really critical to solve, and there is always a possibility that the system may not exist for the desired output signal. So instead of focusing on the synthesis type problem, in this course we will focus on the analysis type problem, where different input signals are given as an input to the system, and based on this input signal we need to determine what kind of output will be produced by the system. So that's all for this lecture. Thanks for your attention. See you in the next one. Don't forget to hit the subscribe button if you like this lecture.